Hi, my name is Mike Cassidy. I'm the project leader for Project Loon, and I'm going to talk to you a little bit this afternoon about what Project Loon is all about. 2 out of 3 people today in the world do not have internet access. That's 5 billion people who don't have access. In some cases, they don't have any signal at all. In some cases, it's unaffordable to them. For 2/3 of the people in the southern hemisphere, the average monthly internet access cost exceeds the average monthly income for someone in that country. So this project, we hope, is good for people who don't have access to start with, but also is good for people who have access that gets interrupted, like we're talking about the Philippines, in case of a natural disaster. Project Loon works by having balloons that float 20 kilometers up, twice as high as airplanes fly, and broadcasting internet all around the world. The balloons are designed to last hopefully 100 days at altitude. The way the system works is there's a ground station that beams internet up to one balloon, and then from balloon to balloon it can hop 5 balloons across, up to 5 balloons, and then down to an end user. Currently we can go 200 kilometers horizontally from a ground station with internet access to an end user. In the future we'll be able to go 1,000 kilometers from a ground station to an end user, 1,000 kilometers horizontally. These are just a picture of one of our very early balloons. This was one we constructed ourselves out of mylar and tape. It flew about 100 kilometers across the Central Valley and lasted about 4 hours in flight. This is a picture of what our payload looks like. It's a styrofoam box about 12 inches square and about 18 inches tall. And in the upper right-hand corner, you can see a small fan. That fan pumps air into a ballonnet. A ballonnet is a balloon inside a balloon. The outer balloon is filled with helium. The inner balloon is filled with air. And what we do is we pump air into the bottom, into the ballonnet. It makes the balloon heavier. And we can drop down from 21 kilometers down to 20.5 or 20 kilometers or 19.5 kilometers. And that lets us guide the balloon where we want it to go around the world. One of the key innovations of this project was the idea of having the balloons not remain over one place on the ground. People previously had thought about putting a high-altitude platform to broadcast internet. But in those ideas previously, they did one of 2 things. They either had a tether, a cable running from the ground all the way up to the balloon, which has concerns about airplanes crashing into the cable, or they used a propulsion system on the balloon to maintain its station, a continuously spinning propeller to keep it in one place. Well, do you need to refuel it? If you use solar panels, what do you do at night? Turns out no one was able to find a successful solution to that. Google, instead, we decided to have, as one balloon moved naturally with the wind out of range, another balloon would come and take its place. It's kind of like the opposite if you drive down the highway with a cell phone and you switch between cell towers. Here you're remaining stationary in the ground and the cell towers are moving over you. This is a graph of the winds. We need to know all the wind directions at various altitudes in order to put the balloon where we want it to go. And I'm going to show you a video of one of the simulations we used when we were designing the project. There's 5 red dots you can see in South America and Australia. Imagine those are the dots we're trying to provide coverage to. You see the balloons being launched. This is a simulation using real wind data and the control authority we have on the balloon. By raising it and lowering it to find winds going the direction we want, we can basically put the balloons where we want. For example, you can see them hovering over this area in Western Australia, and you can even see balloons heading back westward when they're catching a wind to take it back to the area they want to cover. This means you don't need to uniformly distribute balloons every 40 kilometers over the entire Earth. You can put them exactly where you need them, and makes the system much more efficiently. And that simulation was using real wind data and real control authority of the balloon. The next video I'm going to show is real data from when we launched in New Zealand. We did a pilot test last June The blue lines are showing the projected trajectories of the balloons. The green circles show the area of coverage of internet as the balloon goes higher in altitude from its launch, about 50 miles west of Christchurch, New Zealand. As the balloon rises higher, the area of coverage increases. Simple geometry. The goal is to have overlapping circles providing continuous coverage. And you can see we were able to do that on our launch day. This is about 4 hours compressed in about 25 seconds. And provide continuous coverage. We'll do that in large scale over the whole world. The next video I want to show is an actual launch. This is in a little bit west of Christchurch, New Zealand again. We've got 5 balloons lined up, and we're going to launch one after another. The balloons rise at about 3 meters per second. That square thing you saw at the bottom is a solar panel. These are very green balloons. Once they are launched, they're completely environmentally friendly. They're powered by the sun. We have batteries that power them overnight. It takes about an hour for the balloon to go from launch to reach its altitude, cruising altitude of 20 kilometers. And they are underinflated when you start because the density of the air 20 kilometers up is only about 5% of the density of the air on the ground. So you only put about 5% full of the balloon, so by the time it reaches the top, it's pumpkin-shaped. I'm going to show you one more video, which is the very first non-Googler in the world to get internet access.
I run a small farm. When I'm using the internet, the first thing I'll check is the weather, see if my sheep are going to dry out, and at the moment the wool's not dry. So I'm just looking for a window so I can plan my week.
All right, coming out, 3, 2, 1. Straight up, straight up, straight up, straight up.
Bingo.
Yay!
And that was fast too. To be the first person to do that is a little bit cool as well.
This project's a little bit cool project to work on too. It's real tough to go down to New Zealand for the launch. Yeah, we went in the winter, unfortunately. June is the winter in New Zealand, but I hope that we're going to be going back next month. It's supposed to be a nice time to go next month. Here's just a quick few more slides. A map of New Zealand, and the yellow area is the area south of in the South Island called Canterbury, where we launched our pilot test. And you can see in the lower left-hand corner the beautiful sunrise on the morning we did our pilot test. South Island, New Zealand is, I think, one of the most beautiful places I've ever been. So that's it. It's pretty quick. I'd be happy to answer questions. But this is a GoogleX project. GoogleX is the group inside Google that tries these called moonshot ideas. Some of the other projects at GoogleX are the self-driving car, Google Glass, and now internet from balloons 20 kilometers up. Go ahead.
What do you think about for balloon-to-balloon communication?
The question is, what kind of communication are we doing balloon to balloon? We're currently doing 5.8 gigahertz RF. And for 40 kilometers between balloons, that works fine. We think we can get many tens of megabits per second, and we're currently providing 3G service to the ground, single-digit megabits per second. Go ahead.
Yeah. My question was, it stems from a concern that you guys sent it from New Zealand, but it covers the entire Pacific Ocean, where there's no one to get internet. So my question is, where are you going to start the first launch?
So the question is, Mike, if you're going after New Zealand, there's a lot of Pacific and Atlantic Ocean down there. Is it really the most efficient place to start? There's a benefit to starting down there, and that is it's simpler operationally in terms of the number of countries you're coordinating with when you launch. We're only coordinating with New Zealand, Australia, Argentina, and Chile, and all of them were very happy to work with us, very eager. By the way, we have 28 countries now who have asked for us to come to deliver internet to them. The one video I showed with showing how you can speed up the balloons over the place you don't need to provide coverage. The stratosphere, where we fly, is named the stratosphere because the wind is stratified, and it goes different speeds at different layers. And so it's actually not too hard to find an altitude that makes the balloons go quickly over the area you don't need coverage and spend more time where you do need coverage. So thanks for that question.
And I guess a follow-up with that question, is there a way to transmit that wireless connection through the balloons faster? You're saying physically the balloons can go faster than the stratosphere. Right, but what about the actual wireless connection that jumps from one balloon to the other? Because you says it goes up to 5 balloons, correct?
Yeah, so it's speed of light limited. It's RF, so we can't go any faster than that.
Right. Okay.
But we can. It's actually interesting. It's an advantage of the balloon system. Many people don't know this. Light actually travels faster through the air than through glass fiber. So it's actually faster to go a couple hops through balloons than to go through a fiber.
Okay.
Other questions? Go ahead, please, in the red.
You did talk about making these environmentally friendly. If you had enough balloons to cover the Earth and they're not going to stay up there forever, what would you do to the ones that fall down and crash? How would you clean that up?
Right, great question. Mike, aren't you going to be environmentally friendly? What about all these tens of thousands of balloons? Aren't they going to come and land in the ocean? The team cares a lot about that. We basically have the ability to bring the balloon down where and when we want it to. There's a lot of electronics and actuators in the balloon. So we can open up the top of the balloon, a small hole, and we are to the point now we can pretty much bring it down within about a half a kilometer of a spot we want to land in. So we're designating approved landing zones, the western outback of Australia, big parts of Nevada and Utah, where we can bring the balloons down in a controlled manner and then collect them. And in fact, we want to reuse the electronic payload. So it's some printed circuit boards. You saw the little fan there. It's coming down pretty gently at about under 10 miles an hour. Should be able to be reused. We won't be able to reuse the plastic because any even pin size hole will basically bring the balloon down in a couple of days. But we think we'll be able to recover and reuse the electronics and recycle the plastic. But thanks for that good question. Go ahead.
So let's say in the future we have thousands of these balloons, right? Millions of these covering the Earth. How would our clearance for planes work? How would our birds survive? You know, these are new things we're introducing into our ecosystem.
Right.
So how would the humans and the natural life survive with these pretty things around?
Great. So how are humans and natural life going to survive with all these millions of balloons? So hopefully we'll only need tens of thousands of balloons. The good news about balloons is they're 20 kilometers up. So they are twice as high as airplanes fly. Once they're at altitude, there's no risk of a collision between a balloon and a commercial airplane until they come down again. When we come down, we're always coordinating with the FAA. We follow all the FAA rules. There's flashers on the balloons. There's a transponder on the balloon that broadcasts its position. There's a radar reflector on the balloon. And we actually call the FAA in regions we're going up and going down and say, hey, and we're on first name basis with the FAAs now. Hey, we got another balloon coming up. We launched 7 on Wednesday. And we said, here's its altitude and direction. And we know where the planes are. They know where the balloons are. And we avoid the problem that way. Go ahead, please. Okay, so the question is, isn't Google doing another project called O3B? And what speeds are we operating? We're operating at 3G speeds, single-digit megabits per second. And Google actually has multiple approaches to trying to provide access to many people. That's one of the cool things I think about Google is they don't have like one project. There's a pretty cool fiber project, which is bringing very high speed gigabit internet. There's O3B, which we support. There's a variety of other ways of trying to get. So there's no sort of single solution. Google likes to try many ways to increase access. Vint.
Yeah, I just want to reinforce the observation. We are investors in O3B and big supporters of that project. I think the whole point here is that there won't be anywhere in the world just a single way of getting connectivity to the internet. That's as true here in the United States as it is in other parts of the world. So it's actually really important that Google and others see a variety of ways to invest. You mentioned gigabit networks. Not only are we doing it in the United States, in Kansas City, in Austin, and Provo, but we're doing it in Uganda as well. So I think actually it's important that you have multiple ways to do this.
Great.
I was just going to follow up on that. I think there's some countries that even mandated as human rights.
United Nations. United Nations also added it to its hierarchy of needs. Go ahead. There was a question over. Go ahead.
You're talking about global coverage, and so how do you, once you get to the 10,000, 50,000 that are required for that, how do you deal with airspace, sovereign airspace issues? Let's say China, Vietnam, where they have tightly controlled telecommunications.
I wish the question is sovereign airspaces. Do you need to coordinate with different countries as you overfly them? And also, what about countries that may have tightly controlled information? This is a case where I wish I could say everything I know, but unfortunately I can't. We have been extremely successful with getting overflight permissions basically almost everywhere in the world, including places you'd think maybe wouldn't. And also, similarly with countries that some might think are maybe not as open to providing information, are actually eager to provide information to people in their rural areas who don't have access. There's tensions in some places where some governments actually want to bring information to people in the rural areas. So it's going much better than some fears had thought it might go. Other questions? Go ahead, please.
Since there's obviously a big difference between New Zealand and the next landmass as you head towards South America, you have all this ocean. Are you advertising to just sailors and boaters and people that are out there that could they maybe be a part of the program, or even in other areas of the ocean? Would they know ahead of time if you were doing a balloon project above, say, the plastic gyre up in the North Pacific?
Right. So will this be useful to people in the middle of the oceans? Yes. We've already had requests from a pretty remote penguin hatchery in somewhere in the South Hemisphere near the Antarctic Circle that didn't have any communication, and they were very excited about this being able to be. Also, I wish I could remember her name. She's on our advisory board. She's very excited. She's one of the leading oceanographers. Very excited about when people study the ocean. That's another issue they have, collecting data. And they can put buoys out and things, but there's generally no way for them to collect the data. This is a gold mine for them. These balloons will be able to pick up the data. And we also think it'll be quite useful for boaters because there are some systems for providing communication in some areas in the ocean, but many of those are extremely expensive, whereas this project is designed to be super low cost as one of its primary goals. So thanks for that. Go ahead, please.
Are you worried about running out of helium?
Another great question. The question is, what about running out of helium? There is a limited supply of helium, and we are exploring hydrogen. Many people hear hydrogen and they think, ee, but actually there's ways of being safe with hydrogen filling and making sure you don't have too high concentration of hydrogen gas sort of during the whole fill and launch process. And as you descend, make sure you do it safely descending. But yes, we'll have to look at hydrogen because the helium is limited. Go ahead in the back.
Yes, it's my understanding that in the New Zealand experiment, you had to have a special receiver to communicate with the Loon satellites. Is that something that you're going to get rid of? I mean, is this going to be internet
our goal is to make it as easy as possible for people to have internet access. So I hope in the future we'll be able to do that. Sorry, I can't say more. Go ahead.
So will you charge for this? And they kind of structured for compensation?
So the question is, will we charge for us? Yes. One of our business models is to work with the telcos in various countries. And in many cases, they're very excited about this partnership. We often start the conversation by saying, what does your capital expenditures look like over the next 3 to 5 years to build cell towers in all these locations? And they say $3.6 billion or $7 billion. And we say, well, how about if you don't have to build any more of those cell towers, we'll put the cell towers up 20 kilometers up and we'll work out a revenue share agreement. And 10 out of 10 have said, yes, that sounds great. So I think we're very excited about ways of bringing low-cost internet to places, you know, that many broadband providers also look to provide, you know, low-cost people, you know, humanitarian organizations or educational organizations, things like that. So that's very much in the cards. Other questions? Go ahead, please.
Well, one would imagine a number of places where tethered balloons, well, for instance, they're going to be putting up a huge guy, the Air Force is going to be putting up a huge one over Washington, D.C. And then in the ground in between, there ought to be lots of places on Earth where you could license and legally put up tethered balloons that stay in place.
Okay, so the question is, why not use tethers? I mean, shouldn't you be able to find places where it makes sense to do tethers? It could be. I think there's a couple challenges with tethers. If you do a relatively low flying balloon, pick a number, 500 meters, 1 kilometer up, you're definitely in the weather. When hurricanes come, when things like that come, if you examine the wind loads on a tether, it's quite dramatic how strong that tether has to be. And there's also issues with collisions. You know, planes do, you know, fly that low. If you want a longer tether to sort of avoid some of the weather, we've looked at that. The weight of the tether gets to be very significant. You're talking thousands of kilograms for a tether to put you up, you know, sort of over 10 kilometers up. But it's an interesting idea. And unfortunately, thanks it from the Q&A. I'm glad people came. Glad I got to present Project Loon to you and enjoyed the great questions. And hopefully stay tuned for more from Project Loon. You can find us on Google+. I think you can follow us. So thanks very much.